Okay, hello students. Today we are going to start the next topic in relations and functions. We are going to discuss theorems now. We'll start with this. This is the last topic. We are going to discuss the proof for some functions and then go to next chapter. Theorems. We have already discussed the properties. What are nearly 7-8 properties we will discuss, and we are going to see the proof for those in this time. Okay, theorem 1. If f and g be two functions and h is another function, three functions, then prove that h of g of f equal to h of g of f. That means it is nothing but associative property. We need to prove the associative property of composition of functions. We will see the proof here. First, when we can say two functions are associative, this condition should be satisfied. We can interchange the bracket. Okay, what is g of f? First, we have to find g of f and h of g to prove this. First, we will see what is the domain and codomain of both the functions. So, here g of f is a function. How to take g of f? G of f is the input of this. So, g of f will be a function from a to c. G of f is a function from a to c. Now, I already discussed how to write this g of f. We should take the input of f function, that is input of f function a, take this f, and then output of g function, that is from a to c, that is g of f. Now what we need to find is h of g of f. Now g of f is a function from a to c and h is from c to d. Now how to find h of g of f? Again, g of f is the input, so we will take a, and h is the output, so d. So this function will be from a to d. What is h of g of f? It is a function from a to d. A to d. H of g of f is a function that maps from a to d. Similarly, we should find h of g of f. Just now we have discussed h of g of f. Now we should find h of g of f. Again, what is h of g? H of g is the input. So it is b. And h is the output. H is the output. So output of this function is d set. So it is a function from b to d. H of g is a function from b to d. Similarly, what is h of g of f? H of g is from b to d and f is from a to b. So h of g of f, that will be f is the input here, a, and h of g is the output, that is d. So again, this function is also from a to d. From these two examples, what do you observe? H of g of f and h of g of f, both are functions that is mapped from set a to set d. So h of g of f and h of g of f both have same domain. Remember, whenever we talk about domain, it should have image for all the elements. Only then this qualifies as a function. We already know what is a function because each element in the domain should have some image in other set. So therefore, domain of both the functions is same, that we can understand. But here set D is the codomain and set D can have, that is codomain, range can be any value within the set D. So after confirming both the functions have same domain, we should check the range of the function. So for part 2, how to check the range of function, we will discuss now. So let A is the element in set A. Let's assume A, B, C are elements in set A, B, C. Now h of g of f of A, that is nothing but we should substitute some value of A. What is the output? h of g of f is a function from a to d. Therefore, input is some value element a. This has output some b. H of, we can write this function as h of g of f of a. And by the associative property, we can write this as h of g of f of a. H of g of f of a. And what is h of g of f of a? It is nothing but h of g of f. So both are same. H of g of f is equal to h of g of f. Both are same. This is the proof for associative property of function. Next theorem is if g are two bijective functions. Remember what is a bijective function? Bijective function is nothing but a function that is both one to one as well as on to. So a bijective function, f and g are bijective functions. Then we have to prove that g of f is also a bijective function. Now students, question can come in the ways like either they can give the set and ask you to prove for that set, or they can give a function, say polynomial function or linear function, any kind of function, and ask you to check the property if this holds true or not. Questions can be asked in any ways, or they can also ask theorems. Proof. Now here we have to prove that f and g are two bijective functions means g of f is also a bijective function. Let's see the proof for this. What is given? F and g are bijective functions. What is bijection? We already know. It is both one to one as well as on to function is called bijective function. As f and g are one to one and on to, it satisfies the property of that. That means f and g are functions. We know that g of f is a function from set A to set C. First we will write what is g of f. We need to prove g of f is also a bijective function. That means first we should ensure if this is function or not, and then check for one-to-one property and onto property. Is as simple as that. So what is? First we have to prove if this is one-to-one function and onto function. Before that we should check if this is a function or not. So here f and g are two functions. Then g of f is a function that is mapped from set A to set C. G of f is a function. We already know how to write g of f. G of f. So input is f, output is g set. So input is input of f, that is A, and output is output of g set, that is C. So g of f is a function mapped from A to C. G of f is a function mapped from A to C. That means it is also a function first. That we can ensure. Then what we need to do? If this is a bijective, first we need to prove if it is one to one or not. To prove that this is one to one, how do we first normally prove one to one property of a function? We will assume two y values, and from that we will ensure x values are also same. F of a1 equal to f of a2 implies a1 equal to a2. That is the condition, that is the working procedure for proving one-to-one property of a function. So here what we will do is take any two values f of a1 and f of a2. What will be these elements? This will belong to set B. Why is that? Because f of some input. What is f function? It is mapped from A to B. Therefore f of a1 will be an element in set B, that is output of f, and f of a2 is similar to that. It is also an element in set B. As f is a function, these images are fa1 and fa2. We already know that. Hence these values will belong to C set g of f of a1. What is g of f of a1? F of a1 is an element in set B. That means if you are taking composite with g, that means g of f of a1, that will be the output of, what is output of g? That is C. So these two elements will belong to set C. Now what we need to prove is g of f is also a bijective function. G of f of a1 equal to g of f of a2. Let's assume this. For proving g of f is a bijective function, that means g of f of a1 equal G of f of A2 implies A1 equal to A2. That is what we need to prove. So the proof is as simple. G of f of A1 equal to G of f of A2. First let's assume this. From this what we need to get? A1 equal to A2. That's what we need to prove. As G is a bijective function, we are already given f and g are both bijective functions. What is the condition for bijective functions? It is 1 to 1 as well as onto. What is the condition for 1 to 1 function? F of A1 equal to f of A2 implies A1 equal to A2. Therefore, G of f of A1. This f of A1 is the input for G. F of A2 is the input for G. As both these values are same, output of G function is same. Therefore, input should also be same. That is what is given. G, f of A1 equal to f of A2. F of A1 equal to f of A2. That is, G is 1 to 1 function since G is 1 to 1 as it is bijective. That is given in the question. And f is also 1 to 1 as f is also bijective. Therefore, what we can say? A1 equal to A2 as f is the output of some value. F function is the output which gives from B set. Similarly, f of A2 is also an output in B set. So that means input should also be same. That is A1 equal to A2 since f is also a 1 to 1 function. Which means G of f is a function from set A to set C is 1 to 1 function. How do we determine this? Again I will tell the procedure. What we need to prove, I will explain in short. F and G are two bijective functions. Then we need to prove G of f is also a bijective function. That means first we have to be clear in our mind what we need to prove. What is the condition for bijective function? It should be 1 to 1 as well as onto. Now if this function is a bijective function, that means G of f is a 1 to 1 function. What is G of f? Is a 1 to 1 function means we should take some values. G of f of A1 equal to G of f of A2 means A1 equal to A2. That is the first condition for proving 1 to 1 property. This is the proof for that. Next, what we need to prove? Check if this function is onto or not. What is the condition for onto function? Range should be equal to codomain. Let's check this also. To prove that G of f is onto, let C be any element in codomain set C. Okay, G of f is onto. That means range should be equal to codomain. For range as well as codomain, we will consider the output function, output set, that is nothing but C. So what we will take is, let's assume some value C is any element in codomain set C. Now what is the condition for onto? Range is equal to codomain implies each element in codomain have some pre-imaging domain. That is what we need to prove. Now let C is the any element in codomain set C. And G is onto function because f and g are bijective. That is given in the question. So G is onto function means for every C there exists some element B in set B. For every C there exists some B in set B such that G of B. What is the function? G is the function. So G of some element B will give an output C. G of B equal to C. Now similarly f is also onto. That means some f of A equal to B. F of A equal to B. We can understand these two conditions from the given question. Next what we need to see? Find G of f is 1 to 1 and onto or not. From this, what is C? C is nothing but G of B. And okay, C is G of B. Use these two conditions. C is G of B and B is f of A. So this is nothing but G of what is B? F of A. Substitute in this. That is nothing but G of f of A. C is G of f of A. Now that means for some C in set C there exists G of f of A equal to C, and this value input is nothing but A. which belongs to set A. That means for every element in A, there is a corresponding image in set C. As well as all the elements in set C have some pre-image from set A. That is what is understood from this statement. As C is semi-arbitrary, every element in set C has pre-image in domain A under G of F. So that is what is concluded from this statement. So what we understood, students, G of F is nothing but a function that is mapped from set A to set C, and if it is a bijective function, we need to prove if it is one to one as well as onto. Now for proving one to one, we just need to compare if two outputs are equal, input should also be equal. That is the condition for one to one. And what is the condition for onto? Onto is nothing but for every element in codomain, there should exist some element pre-image in domain. So that is what we proved from second step. So from both these steps, we understood that G of F is a one-to-one as well as onto function. So that is nothing but G of F is bijective function. That is the proof for second theorem. Okay, next theorem. If F and G are two bijective functions, then we need to prove G of F inverse equal to F inverse of G inverse. This is the most popular and standard type of question. Most times they will ask questions. We have to solve for certain sets or functions. They will give the set or function value and we should verify this property. Questions will be asked majorly like that. Now we will discuss the proof for this theorem. Now what is the proof for this? G and F are both bijective. That is given. G and F are two bijective functions. Okay, what is understood from bijective? It is both one-to-one and onto function. First we have to prove G of F inverse, F inverse of G inverse have same domain. For proving two functions composition, we should check first if domain is same for both this composition as well as then take the range and see if that value exactly matches or not. Now this is okay, domain is same. First we have to prove if they have same domain. What is the condition for proving same domain or not? That is, we have to check the one-to-one nature of the function. A to B is function from F is a function from set A to set B and G is a function from set B to set C. Both are bijective functions. Now what is G of F? We should find G of F and its inverse. G of F is a function which has an input of A and output C. That is, G of F is a function from A to set C. And what is G of F inverse? We already know what is inverse. Inverse is nothing but the reverse. We should change the input and output, just ulta. That is nothing but set C to set A. G of F inverse is a function from set C to set A. Now what is the domain of G of F inverse, students? That is C. So F and B are bijective. Okay, next we should find g of f inverse is a set from element. It is mapped from set C to set A. This is inverse of g of f. Now what we need to prove? F inverse and g inverse. We should find f inverse, g inverse and take the composite of this. What is f inverse? F inverse is a function mapped from f inverse will be from b to A and g inverse will be from C to B. Now what is f inverse of b inverse? F inverse of g inverse. That is a set mapped from g inverse is the input, that is C, and f inverse of output is A. So it is also a set from element is mapped from set C to set A. So what we understood from this, for both the functions input is set C, that is domain of both the functions is same. So that means first we ensured this property, both the domain is same means it is a one-to-one function. Then next we should check the onto property, onto nature of the functions. Now C is any element in set C. Let's assume C is any element in set C and G is element from, it is a function map from set B to set C is a bisection that is given, which means G is onto function. So what it means, for every element in set C there exists some element B in set B. That is the understood from this. So for every element in set C there is a unique B in set B. That is nothing but B equal to G inverse of C, or G of B equal to C. Also f is also a bijective function. That means again we can take any element in set B have some image, pre-image in set A. For every element in set B there is a unique element in set A such that f of A equal to B, or B equal to, A equal to f inverse of B. And we already know G of B equal to C. Just replace this value here. F of A equal to B. That means in place of B we are writing f of A. So G of f of A equal to C. G of f of A equal to C. Now G of f inverse of C is A. That means obvious, because inverse of output will become input and input will become output for inverse function. So G of f inverse is nothing but input of this value, that is A. And what is f inverse of G inverse of C? Input of G inverse is C, so we are taking C here, and f inverse of G inverse of C. And what is f inverse of G inverse of C? G inverse of C is nothing but, where is it? I think it is in previous slide. G inverse of C is nothing but B. So f inverse of B, and what is f inverse of B? That is A. Which means both these functions have same element, that is coming as output. So f inverse of G inverse of C is equal to A. From both these values, G of f inverse also A, f inverse of G inverse is also giving the same output. That means both are same. Next theorem. If f is a function from A to B is a function and IA and IB are identity functions in set A and set B, then we should prove that f of I is equal to I of f equal to f. That is nothing but a function composite with identity is given function itself. So to prove this, first we have to find both the function have same domain. It is, every theorem has the same steps, students. It is just easy. You just need to remember these steps. What do we need to do? Whenever bijective nature of the function is given, that means it is one to one and onto. and then to prove a function is bijective, we should prove first if it is a function or not, and then check the domain of both the functions from both sides, left hand side and right hand side, and then take the range or onto nature of the function. So here f is a function and I and b are identity functions, means we should prove that f of I and I of f is both f itself. So for proving this, first we have to check if both the functions have same domain or not. That is, first we will take f of I. I of a is nothing but, identity is nothing but y equal to x. That means every element in set A will be mapped to set A itself. So this both the values input and output are both same. That is what is called identity function, y equal to x. So here set A, A means elements in set A, identity in set A. That is, set A is the input and set A is also the output. So it is mapped from A to A. Now Ia of A is A for every element. Now given that f is a function from A to B, that means f of Ia. F of Ia is input of Ia, that is A, and output of f. So it is a function from A to B itself. That is nothing but it is same as a domain of f. F is also a function from A to B. F of I is also a function from A to B. That means both the functions have same domain. So first we can check this nature. Next, what we need to see? Both the functions have same domain. Next, we should check the onto nature of the function. A is any element in set A. F of I equal to f of Ia of A. Now what is Ia of A? That is A itself. That means this is nothing but f of A. What is f of A? That is B. So from both this nature we can see that f of Ia equal to f. Now we should check Ib of f equal to f or not. This is the second part of the same problem. Now what is Ib of f? Again we have to check the domain for both Ib of f. So input of f and output of I. Input of f is A, output of I is B. So this is a function from A to B. That means f is also a function from A to B and Ib is also a function from A to B. Both have same domain. Next, Ib of f. That is Ib of f of A. And what is f of A? That is nothing but Ib means it is an identity function in B. So output will be exactly same as f of A. Output is same as input. So answer is f of A. From both these values, we can see that f of A is nothing but f function itself. That means input, they both have same domain as well as output is also same. So both the functions are actually same. So Ib of f equal to f, f of Ia equal to f. So all these three functions are same. That is the proof for this theorem. Next theorem, f is a function from A to B is a bijective function and Ia and Ib are identity functions. Then we should prove f of f inverse equal to I. In the previous theorem what we did? We take identity with the composite. F of I equal to f. That means f of f inverse will become I. That is a function. The composite with its inverse will give the identity function. That is the theorem statement. What is given? F is a bijective function. Only when f is bijective we can find its inverse. So this is obvious. Even if it is not given in this statement, when we write f inverse, it is understood that this is a bijective function. Now f of f inverse equal to I and f inverse of f equal to Ia. Now we will discuss the proof. First we should see domain is same or not and then see the range of the functions. First f of f inverse equal to Ib, proof is we should check if both the functions have same domain. that is f is a function from a to b is a bijective, means f inverse is a function from b to a. We should know both f as well as f inverse domain and range. That is f inverse is a function from b to a is also a bijective. That is obvious, because f is bijective means f inverse is also bijective, as f inverse of inverse will become f itself. Okay. Now f inverse is a function from b to a and f is a function from a to b. So what we need to do? F of f inverse, that is input of f inverse. Input of f inverse is b and output of f is a. So this is a function, f of f inverse is a function from b to a. F of f inverse is a function from f is a function from a to b, no? So a will get cancelled, it is a function from b to b. Now by the definition of identity function, IB is also a function from set B to set B. That means domain of both the function is same. Both have same domain. Now we should check the onto nature of the function. So let B be any element in set B. Both domains are B. Let B be any element in set B. And F is a set function from A to B is a bijection, that is given. That means f is a bijection, means some f inverse of b will give a. F of a equal to b, f inverse of b will give a. Also by the definition of identity function, ib of b equal to b itself. So for any element set b, f of f inverse of b will be f of f inverse of b, because both the values are b itself. So this is understood from this. This is a proof for this theorem. Next theorem. Okay, next we should prove the other side of this theorem. That is f inverse of f equal to IA. Proof is similar to previous step. F inverse of f is nothing but, again we should check the domain of both these functions. F inverse is a function from b to a, f is a function from a to b. Input is f, that is a. Output of f inverse is again a. So this is a function from a to a. IA is also a function, identity in a. So it is also mapped from a to a. So f inverse of f is a function from a to a. Identity function IA is also a function from a to a. As this is a function, both the domains of these functions are same. So f inverse of f and IA have same domain. Next, what we need to see? Onto nature of the function. Now for proving onto nature of this function, let's assume some a1 is belong to set A and f is a function from map from a to b. As this is a bijection, f is a bijection, that means for every element in set B, there exists a pre-image in set A, that is f inverse of b equal to a. F inverse of b1 equal to a1. Also by the definition of identity function, IA of A is nothing but A itself. So by both these conditions, both the outputs are same for inverse. That means both these functions have same domain as well as output is also same. So both these functions are equal in nature. Right now, f inverse of f of a1 equal to f inverse of f of a1 equal to f inverse of, what is f of a1? F of a1 is b1. F of a1 is b1. That is it. Okay, next theorem. F and g are two functions such that g of f equal to identity. In the previous question, what we see? F of f inverse is identity. Now what is given? G of f is identity. That means g will be f inverse. Obvious from previous question we can identify this. That is g of f becomes identity, means f and g are inverse of each other. Now for proving this, it is similar to previous proof. First of all, we should prove that f is a bijection, because in this question f and g are two functions, that is alone is given. From this statement also we can identify. In the previous theorem I have explained, if F inverse is given, that means F should be a bijection. Here F inverse is not there in the statement, but what is given? G of F or F of G becomes identity. That means inverse must exist. That is the understanding from this statement. So from this what we can say is F and G are both bijective functions. Only then F of G or G of F will become identity. So first we should prove that F is a bijection. That is nothing but one-to-one and onto nature of the function. And F is one-to-one means, how to prove this? We will assume two values in set A and see if the input is also same. So let F of A1 equal to F of A2 means we should prove A1 equal to A2. Now for proving this, what is given? G and F are two functions, is that G of F is identity, that is given. So first we will find G of F. What is G of F of A1? G of F of A2, as F of A1 equal to F of A2. We have assumed this first. That means if these two are equal, G of F's identity is given. That means G of F of A1 is nothing but A1 itself, and G of F of A2 is A2 itself. From this we can say A1 equal to A2. That means A1 equal to A2 means this is a one-to-one function, because input of F is A. F of A1 equal to F of A2, A1 equal to A2, which means F is a one-to-one function. Now we should see if this is onto or not. Again, let B be any element in set B, then G is another function given, such that for every element in set A, G of B equal to A. We will assume this first. Let B be any element in set B, then as G is a function from B to A is a function, which means for any input in B, that will give us the output in set A, that is G of some element B equal to A. Now B is nothing but IB of B. Obviously identity in B is B itself. So this is F of G of B. What is this? F of A. This is the proof for this. So every element in set B has some image in set A, pre-image in set A. Therefore, F is onto function. What is the condition for onto? Every element in codomain has some image in domain, pre-image in domain. Now similarly we should see if G equal to F inverse or not. For proving this, F is a function mapped from A to B is bijection. That is what we have discussed till now. As F is a bijection, so F inverse exists. Now what is F inverse? It is a set from B to A function from set B to set A. This is also a bijection function. And G is also a function from B to A. That means both the domains of F inverse and G are same. What is the condition for proving G equal to F inverse? Both the domain should be same and range and codomain both should be same, and every element in this codomain should have a pre-image, same pre-image in the domain of the function. So G and F inverse have same domain. That is what we established now. Next what we need to see if both the range is same or not. Now B is any element in set B. G is from B to A is a function for every A in set A. G of B equal to A. That is obvious. G is a function from set B to set A. That means what does mean? G of some element B equal to A. That is what is given. Then F is also a bijection. That means F of A equal to B. F of A equal to B. That is F inverse of B equal to A. And what is A? G of B. So substitute in that. That means F of G of A equal to B. That means F equal to G inverse. This is as simple as that. Students, this question may seem confusing, but take time and revise once again. It is actually very simple. You just need to remember 3 steps for solving these questions. One is, first we need to establish if this is a function or not. Second, check for onto nature of the function. Third, check for onto nature. If the codomain, if every element in codomain has same pre-image in domain or not. That is as simple as that. We just need to remember these 3 properties. Next theorem. F is a function mapped from set A to set B, and G is a function from B to G or B to A are 2 functions. G of F is 1 to 1. Then F is also 1 to 1. This is the first statement. G of F is 1 to 1 implies F should be 1 to 1 function. And G of F is onto means G should be onto function. You should remember these 2 properties very well. One is G of F is 1 to 1. G of F is 1 to 1 means input should also be 1 to 1. That is F. Input of G of F is F. That should be 1 to 1. Normally, how we find 1 to 1 nature of the function? We will take the first element, first set, that is domain. We will check 1 to 1 or many to 1 function from the domain. So G of F is a 1 to 1 function means F should be 1 to 1. Remember it like that. Second statement, for onto nature of the function, we will see the codomain because range should be equal to codomain. So here G of F is a function, is a onto function means then what is the output of this? G, that is codomain. So G is also onto function. Remember it like this. So we will discuss the proof for this. Proof for first statement. G of F is 1 to 1 means G of F of A1 equal to G of F of A2 means A1 equal to A2. That is what we need to prove. F of A1 equal to F of A2. Let's assume F of A1 equal to F of A2. G of F of A1 equal to G of F of A2. As G is a function, G of F of A1 equal to G of F of A2, which means A1 equal to A2. How do we get this? What we did is, for some A1, A2 in set A, G of F is a function map from A to C. So we will assume some value input in set A, that is, let's take A1 and A2. F of A1 is the input first, F of A1 and F of A2. And we composite this with G function, that is G of F of A1 equal to G of F of A2. Now what we did is, as G of F of A1 equal to G of F of A2, this automatically implies, as this is a 1 to 1 function, which means as outputs are same, input should also be same. What is the input of this function, students? A1 and A2. So input A1 and A2 are also same. This is given. Okay, next. As F of A1 equal to F of A2, we have taken this condition F of A1 equal to F of A2, which gives us the output A1 equal to A2, which means F is also a 1 to 1 function. I think this is clear. I will repeat it again. What we did is, first we are assuming F of A1 equal to F of A2. We don't know, we should establish A1 equal to A2. That means F is a 1 to 1 function. We need to prove F is a 1 to 1 function. That means F of A1 equal to F of A2 means A1 equal to A2. So first step is, we are assuming F of A1 equal to F of A2. How to get prove A1 equal to A2, students? We are already given G of F is a 1 to 1 function. So we are compositing this function with G, that is G of F of A1 equal to G of F of A2, which gives us, what is G of F? It is a 1 to 1 function. So input of this function is A1, that means A1 equal to A2. What we assume? F of A1 equal to F of A2. From this statement we got A1 equal to A2. That is the proof for 1 to 1 of F function. For second statement, C be any element in set C. For proving onto nature of the function, we will assume some element in say codomain and see if it has a pre-image in domain or not. So let C be any element in set C. As g of f is a set function from set A to set C is onto, that is given. G of f is onto function. We need to see what is the codomain of this G. So its output is C. So we need to see if this is also G is also onto or not. G of f is C. G of f of A is C. That means pre-image of C is f of A. This is under G. Under function G, what is the input? That is f of A. Now G is onto function as every element in codomain C has pre-image in domain B. That means this means G is an onto function. I will repeat this statement again. C is any element in set C. What is given for us students? G of f is onto function. We need to prove G is also onto function. Remember the statement? G of f is an onto function means G is also onto function. So here what is given? G of f is onto, which means for every element C in set C, there exists some element A in f of A. That is nothing but B set. So for every element in C in set C, there exists some f of A under G. Now G is also onto function because every element has some pre-image in B. That means this is an onto function, obvious. That is the proof for this statement. Okay, with this we have completed this unit, students. Next we will start the next chapter, that is inverse trigonometric functions. Another interesting chapter. This is the second unit for both revision students. This is inverse trigonometric functions. Another interesting topic is this. Until now what we discussed? Functions, relations, composition of functions, inverse of a function, and we have covered all the theory in detail up to now, and I have seen the proof and properties of composition as well as inverse functions. Now we will discuss inverse trigonometric functions. Okay, what is an inverse trigonometric function? This heading itself has three parts. Inverse, we know what is inverse. For inverse to exist, function should be bijective. We have seen in previous chapter. Next, what is given? Trigonometry. That means we are going to discuss about trigonometric functions, inverse of trigonometric functions. Okay, we already know what is function. In this chapter, we will mainly cover these three topics. One is reducing a trigonometric function into a bisection. That is important because trigonometric functions not all are bijective functions. We will discuss this one by one. Bisection means one to one as well as onto. Next, graph of inverse trigonometric functions. We will see graph of trigonometric functions as well as inverse trigonometric functions and compare. We already know how to draw graph of inverse functions. I have discussed this in the previous chapter. Now we will see how to draw inverse for trigonometric functions in this chapter. How to draw graph of inverse of trigonometric functions. Next, properties of some inverse trigonometric functions. First is sine inverse x. Now before going to this topic, we need to understand how to draw graphs and what is the graph of sin x. Before going to inverse graphs, first we need to know how to draw graph of sin x. Okay. First we will start with this graph of sin x. What is the graph of sin x curve? Sin 0 is 0, sin 90 is 1, sin 180 is 0, sin 270 is minus 1, sin 360 is again 0. So graph goes on like this. Similarly on negative axis, it is also like this. 0, 180, 360, 540, it goes on like this. Similarly on negative side also, minus 2 pi, etc. Now what do we understand from this? By the looking of this graph, we can see that this is obviously not a one-to-one function. We know for finding inverse of a function should be bijective in nature. What is the bijective nature of function? It should be one-to-one as well as on-to. By the graph, we can understand that this function is not one-to-one. It is actually many-to-one function. How to identify function is one-to-one or not? By horizontal line test. If we draw a horizontal line, if this line intersects at more than one point in the function, that means it is a many-to-one function. This is actually many-to-one function. That means we can't find inverse. Then how to find inverse? I will explain this easy. Now this is a many-to-one function. And what is the codomain of this? Codomain is all real numbers are possible. What is the range of this function? Range is minus 1 to 1. Range of this inverse function is from minus 1 to 1. That means for finding inverse, we should restrict the codomain and domain so that range is equal to codomain and domain has one-to-one nature following in the entire interval. So here this function is actually, we restrict the codomain with range. Range of this function is minus 1 to 1. So we will restrict codomain also as minus 1 to 1. Now what is the inverse of this function? Range becomes codomain and codomain becomes range. That means this minus 1 to 1 range of trigonometric function becomes domain of inverse trigonometric functions. Let's assume up to this. Okay. Now I will draw a graph of inverse trigonometric function here. Sin inverse of x. Now how to draw graphs? First we need to restrict the domain as well as codomain. We will mark the domain here. Domain of inverse function, that is range of this function, that is from minus 1 to 1. So we will take minus 1 and 1 and mark it here. Domain is all input value. Remember, always input is plotted in x-axis and output in y-axis. Now this is domain of inverse sin x. Now what we need to do? Find the range of this function. Now how to find range, sir? Normally what we do is, this function should be one-to-one nature. So as this function, see if this is one-to-one or not. This value is minus pi by 2. This is pi by 2, 3 pi by 2. If we consider any interval, say minus 3 pi by 2 to minus pi by 2, it covers all the values, that is from 1 to minus 1, from minus 3 pi by 2 to minus pi by 2. This function becomes 1 to 1 because when we draw a horizontal line, it will intersect at exactly one point, and range and codomain is same for this function. So what we need to do is restrict the branch. First we will consider some branch of this trigonometric function, so this function becomes 1 to 1. That is the first step. So we will restrict the domain or branch of trigonometric function. We can take minus 3 pi by 2 to minus pi by 2, or similarly minus pi by 2 to pi by 2. That also has range and codomain is same, and this function is 1 to 1. Again pi by 2 to 3 pi by 2. This also has range and codomain same value. All these intervals will have same domain is this value. We can take any branch in domain, and range is minus 1 to 1. It covers all the values of codomain. Now what we need to do is take the branch that has 0 or which is very near to 0 and preferably on positive side. That branch is called principal value branch of the inverse trigonometric function. So this value, this branch minus pi by 2 to pi by 2, this branch is called principal value branch. Principal value branch. Now what we do is take this principal value branch and find the range. Plot this as range of inverse function, as domain of trigonometric function is range of inverse trigonometric function, and we will mark only for this. This does not mean this function does not exist for other values. Domain should be between minus 1 to 1, and range can be actually any value, but for this function to exist, as this should become a function, we will restrict the range also here. So this domain is from minus pi by 2 to pi by 2. We will take that value and plot here. Minus pi by 2 to pi by 2. Now mark the value. Just shift this curve to that side. How do we plot sin inverse x curve from sin x curve? Just replace x and y variables, as range is codomain and range is domain and domain is range. So just sin of 0 is 0. So sin inverse 0 will also be 0. Sin pi by 2 is 1. So sin inverse of 1 will become pi by 2. Sin of minus pi by 2 is minus 1. Sin inverse of minus 1 is minus pi by 2. So just plot these values. This curve will look something like this. Now what do we understand from this? Sir, only this inverse function exists within this. Obviously, between minus 1 to 1 alone this function exists. That does not mean this function is not available for other branches. We can plot the value. I will take another color. This value can be plotted for any values. We are just shifting this entire curve by replacing y and x variable. Now for finding principal value, normally we will write the answer in terms of principal value. So sin inverse of minus 1 means this is one answer, minus pi by 2. This will be another answer, minus 3 pi by 2. This will be another answer, this is minus 3 pi by 2, this is 3 pi by 2, 5 pi by 2, 7 pi by 2. There are infinite answers. Now when we plot it like this is actually not a function. Why is that? Because what is the condition for function? Difference between function and relation is by vertical line test. If we draw a vertical line, it should not intersect the curve at more than one point. Here this curve is intersecting at more than one point, so this is not a function. So first, for establishing it as a function, we will restrict the range, that is between minus pi by 2 to pi by 2, and only take the values in between this. I think this is clear, students, now. So between minus pi by 2 to pi by 2, we are plotting the values. Okay. So again I will discuss this in short. What is graph of sin x? We already learned in previous class 11. You already know how to draw graph of sin x. And just change this value entirely. That will be replaced by x, replaced by y, and y is replaced by x. Input becomes output and output becomes input. That gives us this graph. And this is actually not a function. We should restrict the domain and range of this function codomain so that it matches the bijective nature of function. Only then we can say if it is an inverse exists or not. So what we do is take the value and restrict the branch of this function that includes 0 or is near to 0. So when we take minus pi by 2 to pi by 2, it includes all the values in the codomain, that is range equal to codomain. This is an onto function, as well as domain has 0 in it. So that means this branch will become the principal value branch, and we will mark this only for this region. So we will take this region and mark the answer. This is the inverse trigonometric function curve between minus 1 to 1 domain, and range is minus pi by 2 to pi by 2. Okay. So for every bijective function has inverse, that means first for establishing inverse nature of function, we will discuss one by one. Sin x is not 1, we have already discussed as f of 0 equal to f of pi equal to 0, that is sin 0 is 0, sin pi is 0. And f is not a bijection as this is a many to one function. So what we need to do is restrict the domain as well as range of this function, codomain of this function, and plot the curve. So we will take the interval domain between minus pi by 2 to pi by 2. This is the principal value branch of trigonometric function, and minus 1 to 1 is the range. This becomes the codomain. Okay, inverse is just replace b set and a set. And remember always, this inverse trigonometric function is represented by function right minus 1, that is inverse notation, or we can also write arc sine, arc cos. This means arc sine, that means it is sine inverse, that is the meaning of it. This is denoted by sine inverse or arc sine. And also remember, whenever we talk about inverse trigonometric function, input becomes output. What does that mean? What is the input of trigonometric function? Angle. It can be either in degrees or radians. So whenever we talk about angle as the input and output is some value, for inverse function, some value of trigonometric function is the input of inverse trigonometric function, and always remember, output of inverse trigonometric function is always angle. Remember this, it is very important. Don't confuse inverse function as well as trigonometric function. Inverse function always has the output as angle. So sin inverse x equal to theta. Theta is nothing but angle. It can be either in degrees or radians. Normally we will prefer radians because whenever we plot in graph, it is all in radians. This is the graph of sin inverse of x. So domain is between minus 1 to 1 and range is between minus pi by 2 to pi by 2. For example, we will take one example and try to simplify this. Now remember what I told you before. What is the output of inverse function? It is angle. And what is sin inverse of 1 by 2? We should find sin of pi by 3 plus sin inverse of 1 by 2. First we will try to find sin inverse of 1 by 2. What is sin inverse 1 by 2? That means at what value sin theta becomes half. That is the meaning. inverse function input is trigonometric function output. So sin theta equal to 1 by 2 means what is theta? That is how we should think. So here this answer is actually 30 degrees, students. We already know how to find trigonometric ratios. You are learning this from class 10. So you are very familiar with this. Sin inverse 1 by 2 will be 30 degrees. And pi by 3 is 60 degrees. So sin of 60 plus 30, sin 90 degree is 1. So what is the correct option? Option A will be the right answer for this question. Answer is sin pi by 2, that is equal to 1. Next graph. I think sin inverse is clear. We will do the same procedure for all the trigonometric functions. We can find the inverse function for all the trigonometric ratios that we have already learned. That is sin, cos, tan, cot, secant as well as cosecant function. So now we will discuss the graph of cos inverse of x. First again we should see the graph of cos x. Graph of cos x. Cos 0 is 1, cos 90 is 0, minus 1, 0, graph goes on like this. Similarly in negative x-axis, it goes on like this. What is the value? 0, 90 degrees, that is pi by 2, 180 degree, cos 180 is minus 1, cos 270 is 0, cos 360 is 1. Similarly this graph extends to the other side also. So here also we get minus pi by 2, minus pi, minus 3 pi by 2 and minus 2 pi. So this value extends in infinite, all real numbers. So input of cos x is also all real numbers. Now what is the output of this function? It always lies between minus 1 to 1. So we will assume codomain is also between minus 1 to 1 for this function. So this is minus 1 and this value is 1. So we will assume codomain of cos x is also minus 1 to 1 first. That means domain of cos inverse will be again between minus 1 to 1. How to draw graph of cos inverse x? First we will plot the domain. Domain is between minus 1 to 1. And what is the range? We should remember range should be equal to codomain and prefer the branch that has 0 in it and preferably on positive side. So here we can take 0 to pi, that has all the values from minus 1 to 1. Similarly pi to 2 pi, that includes all the values here, or 0 to minus pi, that also includes all the values from minus 1 to 1. So we can take any branch here and we will consider the branch 0 to pi. We will take this branch 0 to pi. This branch is called the principal value branch. Let me write in short as PVB. Principal value branch. Now what is the branch we took? 0 to pi, and mark it. This is the domain of trigonometric function, so it becomes 1 to 1. Now what we do is mark this 0 to pi as the range for inverse function. So this is 0 and this value is pi. Let me write pi by 2 in between. Okay. Now what we do is, we know the domain and range of cos inverse x. What is the domain of this? Minus 1 to 1, and range is between 0 to pi. Now we should plot this graph. How to mark this graph? Again, it's simple as that. Cos x graph is like this. Cos 0 is 1. That means cos inverse of 1 becomes 0. Input becomes output, output becomes input. So cos inverse of 1 is the input, that is 0. Output is 0. Y value is 0, x value is 1. Next what we do? Cos 90 is 0. That means cos inverse of 0 is 90. So when input is 0, output is 90. So this graph will be something like this. Next what we do is cos inverse of minus 1, that is 180, as cos 180 is minus 1. So cos inverse minus 1 will become 180. Graph of cos inverse x is like this. It is as simple as that. So always remember, we should restrict the function so it becomes a bisection. Even if it is not a bisection, we can always restrict the domain as well as codomain of the function so it becomes a bijective function. Then what we do? Take this branch, that is my 0 to pi for cos x, and plot it here 0 to pi in y values. So input becomes output, output becomes input. So graph will be like this for cos inverse x. So cos inverse x has domain minus 1 to 1 and range is 0 to pi. Cos inverse or cos. Cos inverse x output is again theta. Always inverse trigonometric functions has output as angle. Graph of cos inverse x is like this. Minus 1 to 1 is the domain and 0 to pi is the range of cos inverse x. Next, another question. Principal value of cos inverse of this minus 1 by 2. What does that mean? Minus 1 by 2. Input is minus 1 by 2. Where is minus 1 by 2? Here. So corresponding to that, we should check the value of output, this point. And what will be it? Corresponding to this, it will come above 90 degrees and below 180 degrees. We already know cos theta is negative in second quadrant. So answer should be between 90 to 180. Now what value of cos theta is minus 1 by 2? That value should lie between 0 to pi. Remember that. Output of this value, when you say principal value, it should lie in the range that is prescribed, what we discussed till now. So this value, my cos inverse minus 1 by 2 is at what value of theta? Cos becomes minus half. 120 degrees, as cos 60 is half. 180 minus 60 becomes second quadrant, it is minus cos theta. Cos 180 minus theta is minus cos theta. So 180 minus 60, cos of 180 minus 60 is minus half. That is 120 degrees. So answer is cos inverse minus half is 2 pi by 3. Now the next question is, write the value of cos inverse minus half plus 2 times sin inverse half. Again, always remember, when you have to find the value of inverse function, it should have the output as angle. So remember, always answer is angle. Now how to find this? Cos inverse minus half. Just now we have seen what is cos inverse minus half, students. It is 2 pi by 3. That is 120 degrees. Plus 2 times half. What is sin inverse half? Sin inverse half is sin theta is half, that is 30 degrees, pi by 6. So we cancel, this is pi by 3. 2 pi by 3 plus pi by 3 is 3 pi by 3, that is pi. So answer is pi. Answer is pi. Next graph, tan inverse x. Again, this is another simple question, students. We should find the graph of tan inverse x. First, before finding the graph of tan inverse x, we will try to plot the graph of tan x first. Tan x graph. What is tan 0, students? Tan 0 is 0. Tan 90, infinity. Tan 45, 1. So this value graph will be like this, and in negative side it will go like this. So this is minus 90 degrees, 0, 90 degrees. And this graph repeats itself after this interval of pi. So this graph will repeat itself. This is again pi. This value is 3 pi by 2. Similarly, in this side also graph will look like this. This is minus 3 pi by 2, minus pi by 2. So graph of tan x graph is like this. Now what will be the graph of tan inverse of x? Again remember students, what is the condition for drawing inverse function? It should be one-to-one as well as onto function. Is this function onto? For onto function, range should be equal to codomain. What is the range of this function? That becomes the domain of inverse function. Range is all real numbers. That means graph of tan inverse x has all real numbers as the input. All real numbers. So this graph will lie between minus infinity to infinity. It has all the domain values. Next, what we need to see? Range of this value. That will be domain of trigonometric function. And what is the domain? We will consider the principal value branch. What is the principal value branch, students? Remember, it should have 0, and preferably if it is on positive side only, then take the value. So it has all the range values. Here range is between minus infinity to infinity. Try to restrict the domain such that the range is encompassed completely. So this is between minus pi by 2 to pi by 2, and this value lies between 0, minus infinity to infinity. So this is considered as, we will take this branch as minus pi by 2 to pi by 2 as principal value branch. So principal value branch of tan x is between minus pi by 2 to pi by 2. So principal value of tan inverse x is again minus pi by 2 to pi by 2. Value means output. Remember, whenever we talk about value of a function, that means it is always output. For trigonometric function, we call this as principal value branch. When we talk about principal value, that is the output of inverse trigonometric function. Remember the difference here, right? Okay, this is the principal value branch of trigonometric function, that is between minus pi by 2 to pi by 2. So mark the value, students, here minus pi by 2, and this value is pi by 2. Now what is tan 0? 0, that means tan inverse of 0 is also 0. So this point is fixed. Next, what we need to see? Tan of 90. Tan 90, that is infinity. That means tan inverse of infinity is 90 degrees. Input becomes output, output becomes input. So tan inverse 90 is pi by 2. Sorry, tan inverse infinity is pi by 2. Tan 45 is 1. So tan inverse 1 is 45 degrees. Let this be pi by 4. Tan inverse 1 is pi by 4. So graph will go on like this. Similarly, tan inverse minus 1 is minus pi by 4. Tan inverse minus infinity is minus pi by 2. So graph of tan inverse x is something like this. And remember, domain of tan inverse x is all real numbers, and range is between minus 90 to 90 degrees. Okay, so tan inverse x has the tan x has the domain minus 90 to 90, and range is all real numbers. We are restricting the domain as well as range. So this is a bijective function, and just ulta it. Just take the codomain as the domain and domain as codomain for inverse function. So tan inverse x graph is like this. Between minus 90 to 90 degrees, graph is like this. Domain is all real numbers. Next, we will solve one question for this. Principal value of tan inverse of tan 3 pi by 5. Now remember students, what is the graph of tan inverse x? Tan inverse x graph is, output is between minus pi by 2 to pi by 2. And domain is all real numbers. Now here what is given? Tan inverse of tan of 3 pi by 5. We can do this question in two ways. First, find the value of tan 3 pi by 5. Do we know the value? No. Then what we need to do? Try to reduce this function so that tan inverse of tan, we already seen f inverse of f becomes the input itself. So what we need to do is, if we directly take tan inverse of tan of 3 pi by 5, answer becomes 3 pi by 5. Here we need to be careful if this is correct or not. Obviously I will say this is wrong. Why is that? Because we need to be careful if this function is bijective or not. Only then this value is suitable. So tan inverse of value output should lie between minus pi by 2 to pi by 2. This value, whether 3 pi by 5 answer is between pi by 2 to minus pi by 2 or not, it is not. 2.5 by 5 is pi by 2. It is obviously greater than pi by 2. Therefore, first what we need to do is, take this 3 pi by 5 and find the value of angle that will match tan 3 by 5 in the principal value branch. That is the first step. So what is tan of this value? 3 pi by 5. What we need to do? Make this angle such that it becomes a value in the principal value branch. Now how to do that, students? Tan of 90 minus, we can take tan inverse of tan of 180 minus theta. What is tan 180 minus theta? Tan theta minus tan theta, pi minus 3 pi by 5. What is that? We can write it like this. Tan of 3 pi by 5 is equal to tan of pi minus 3 pi by 5. Tan 180 minus theta is in second quadrant and tan is negative. So what we need to do? Subtract, minus, negate this answer. So this is the required answer, minus tan of pi minus 3 pi by 5. And what is this answer? This is nothing but pi minus 3 pi by 5 is 5 minus 3, that is 2 pi by 5. This is equal to minus tan of 2 pi by 5. And now what we need to do, students? This value tan 3 pi by 5 is minus tan of 2 pi by 5. So answer is tan inverse of minus tan of 2 pi by 5. And now what is this answer? Minus tan 2 pi by 5. This is nothing but, we can take minus outside, as tan inverse is odd function. We have seen in graph now. How the graph is this? Tan inverse minus value and plus value will be negative of each other, as this is symmetrical about origin, that is odd function. So this value is actually minus of tan inverse tan of minus tan inverse tan of 2 pi by 5. And now what is the value, students? This is nothing but tan inverse tan, this will get cancelled, and 2 pi by 5 lies in the interval minus pi by 2 to pi by 2. So this is minus of 2 pi by 5. So what is the correct answer, students? Option B. Now see, we should be careful with this. Always remember, whenever we say find the answer for inverse trigonometric function, make sure principal value should lie in the range that is specified. What we found in that. Here obviously it is not there. Now we will go to the next question. Cot inverse x. What is the graph of cot inverse of x? First, for finding graph of cot inverse x, we will draw again cot x graph. What is the graph of cot x? Cot is nothing but the reciprocal of tan. And what is reciprocal of tan? Tan 0 is 0, so cot 0 is infinity. Tan 90 is infinity, cot 90 becomes 0, 1 by infinity is 0. And tan 180 is 0, cot 180 is infinity. So graph will be like this. So this is 0, 90, 180, 270, 360. Graph will go on like this. Similarly on the other side. Graph will extend like this. 0, this is 90, minus 180, minus 270, minus 360. Graph will go on like this. Now this value keeps on repeating after a certain interval. Period is again pi. That means range is nothing but all the real numbers. So domain of cot inverse x will also be all real numbers. What is the domain of cot inverse x? All the real numbers. X-axis. Now what is the range of cot inverse x, students? Range is nothing but first we have to consider the principal value branch. How do we choose the principal value? Between 0 to pi. That is 0 is here, pi is here. So between 0 to pi we can take all the ranges between minus infinity to infinity. This value is covered. So this is considered as principal value branch. And with this principal value branch, we will plot this as range, that is range of cot inverse x, that is between 0 to pi. 90 is in between. Now how to plot the graph? Again range becomes domain and domain becomes range of inverse and trigonometric function. So what we choose? Cot 0 is infinity. Cot 0 is infinity. That means cot inverse of infinity is 0. Cot inverse of infinity is 0. And cot of 90 is 0. So cot inverse of 0 is 90 degrees. And cot of 180 is minus infinity. So cot inverse of this minus infinity becomes 180. So graph of cot inverse x will be something that goes on like this. Is it clear, students? What we did? First restrict the branch of this, that is a principal value branch. We took the principal value branch so that inverse function is possible. So this is a many to one function. We should restrict the principal, first find the value of the branch that suits this function as 1 to 1 as well as on to. So we will take this value of the branch and plot it in ulta manner. That is x becomes y, y becomes x. Input becomes output, output becomes input. This is the graph of cot inverse x. So again, principal value branch is 0 to pi, range is all real numbers. We will take the ulta for cot inverse. And this is given by inverse cot inverse or arc cot function. Output is again angle. Graph of cot inverse x is between 0 to pi, it is a decreasing function. Again, one simple question. Cot inverse of minus root 3. What is cot inverse of minus root 3? By the graph of this function, negative answer will lie between pi by 2 to pi. So answer should lie between 90 to 180 degrees. And what is the value of this function? So that minus root 3 is the input. Just see that. Cot of some angle should be minus root 3. What will be the angle? Cot of 180 minus theta is minus cot theta. That means from this we should find what is cot of 180 minus, when cot will become root 3. Tan 60 is root 3, so cot 30 is root 3. That means cot 180 minus 30 will become minus root 3. So that means cot of 150. What is 150? 5 pi by 6. So answer is option D. Answer is 5 pi by 6. And this 5 pi by 6 should lie in the interval 0 to pi. You should always remember, students, principal value should lie always in the interval that is in the graph. We should not take the other regions. So answer is 5 pi by 6. We will discuss the other graphs in the next class. Thank you, students.